Hello students, today we will discuss about the periodic properties, which is the continuation of our previous class. The module number is 1 and lecture is 7. So today we are going to discuss about the polarizing power, the polarizability, and what is the Fajan's rule. So let's start the class. So students, we are discussing about the periodic properties. So this is the continuation of the previous class. Our chapter name is periodic properties. The module is 1 and lecture is 7. Now these are the some of the objectives of our today's class. That is, we will discuss about the polarizability. So polarizability, what do you mean by polarizability? What is the importance of polarizability? That we will discuss. Now, polarizing power. What do you mean by polarizing power? What is the utility of polarizing power? That is also we will discuss. And at last we will discuss the Fajan's rule, and that is very important. Okay, so first of all, if you don't understand what is polarizability and what is polarizing power, you cannot understand the Fajan's rule. So first of all, we should understand, you should know the basics like the polarizability, what is polarizing power. After that, you can know about the Fajan's rule. You can understand the whatever the Fajan's rule has stated, that you can understand. So these are the recapitulation. Now these are the topics like in our previous class we have discussed about the ionization potential, we have discussed about the electron affinity and also electronegativity. Ionization potential, we have all this the ionization potential, about electron affinity, about electronegativity, about all this we have also discussed the trend. What is their trend along the groups and what is their trend along the periods also we have discussed, and what is the explanation. So this is I'm just at a glance, just I'm repeating. This is the ionization potential. Generally ionization potential is from the outermost orbital. If we want to remove one electron, whatever energy we have to give, that is called by ionization energy. So we have first ionization energy. If we want to remove second electron also, that is second ionization energy, and if we want to remove the third ionization energy, so that is also the third electron, removal of the third electron, and this is the trend of the ionization energy. Now electron affinity. We have also discussed about the electron affinity. Electron affinity, what is this? Electron affinity is generally the energy released while we will add some electron in the outermost orbital of a gaseous atom, neutral atom. Okay, so this is just the opposite of the ionization energy, that is electron affinity. Okay, next is electronegativity. Electronegativity, actually this is a property of a element to pull the electron, bonded electron towards itself. Like if we are seeing here the water molecules, the oxygen molecules, the oxygen atom is bonded with two hydrogen atom. Okay, so among these oxygen and hydrogen, the oxygen is electronegative, more electronegative. That is why, that means it will have the tendency to pull the bonded electron towards itself. So this is called by electronegativity. This property is called by generally the electronegativity. So these are the some of the topics that we have discussed earlier. Now, this is a quick review. Whatever you can remember, I have given one question, that is a factor that affects the ionization potential of an element. Now, you have to answer this question. Okay, you have given 4 options. So among these 4, you have to choose one. Okay, so your time starts now. Yeah, your 10-second is over. Yes, of course, the atomic size. Actually, the atomic size, the ionization potential, ionization energy will be depend on the atomic size. If the size will be smaller, then the energy ionization potential will have the high value, because it is difficult to remove one electron from the outermost orbital to break the after breaking the attraction force of the nucleus. Okay, now this is our today's topic, that is polarizing power and polarizability. So before the Fajan's, knowing the Fajan's rules, some of the basic things that you should know, that is polarizing power and polarizability. Generally, polarizing power is related to the cation and polarizability is related to the anion. This is for cation and this is for anion. Okay, now the ability of a cation to distort an anion is known as polarizing power. Okay, now what will happen while one positive charge and one negative charge, if one positive charge and one negative charge will come closer to each other, so what will happen? The positive charge, what will happen? The positive charge will attract the electrons. Whatever the negative charge, that means the electron rich atom. Here we have the electron density here. Now what will happen in presence of positive charge? The electron will be distorted, and this type of distortion will take place. Okay, so this distortion is generally taking place due to presence of this positive charge. Understand? So that is why what will happen, the power of distorting the electron density. Look, previously the electron density is on the negative one, while it will come closer to the positive one. What will happen? The electrons will move here. These are the electrons. It will move towards the positive ion. Understand? So what will happen? That means this power, a distortion power, the electron will be distorted towards the positive ion. This power is actually called by the polarization power. Now what is polarizability? Polarizability actually the property of the negative ion. It is related to the negative ion. What? The tendency of the anion to become polarized by the cation is known as the polarizability. Polarizability, generally what will happen, the electron density is on the negative ion, right, earlier. Next, while these two atoms come closer to each other, what will happen? The electron will be distorted. Electron will be attracted by this positive ion, and it will go towards this. So polarizability is the property to lose the electron, to be distorted towards the positive ion. This property is called by the polarizability. The anion has this tendency to lose its electron, to distort its electron towards the positive ion, in presence of positive ion towards its. So this property is generally called by the polarizability. Okay, the negative charge will become less negative and after that the positive charge will also become less positive. After this distortion, what will happen? The positive charge will be less positive and the negative charge will be less negative, and that is why that time the covalent bond will created. Okay, covalent character will be created. So if polarization is more, the charge will be less and the covalent character of a bond will increase, and these polarization will uh, decide this polarization will decide whether the bond will be covalent or the bond will be the ionic. Okay, so if the polarization will be more, the charge will be less. That means the positive and negative one, the both elements are bonded with the covalent bond. Okay, covalent character will be high. Understand? So this is called by polarizing power and polarizability. Okay, now this is the Fajan's rule. Fajan's rule, generally, if we know the Fajan's rule, what will happen? We can know a bond will be ionic, will have the ionic character, or the bond will have the covalent character. That we can know. How much ionic character will be there, how much covalent character will be there, that we can know by the Fajan's rule. Okay. Okay, now the rules formulated by the Fajans in 1923 and can be used to predict whether a chemical bond is expected to be predominantly ionic or covalent, and depend on the relative charge of the charge and the sizes of the cation and anion. Obviously, the bond will be predominant, preferably will be ionic, will have the ionic character, and preferably will have the covalent character. All these things we can know, all these things will depend on the size of the ions and the charge of the ions. Okay, so according to this Fajan's rule, the small cation, the high polarizing power, having the high polarizing power, stems for the greater concentration of positive charge on a small area, and this explains why lithium bromide is more covalent than the potassium bromide. Okay, so according to Fajan's rule, now what will happen if the cation will be small? Small cation means the charge is concentrated. That means the charge is high. Nuclear charge is high. That means the attraction force, it can attract the electrons more strongly. That means the polarizing power is very high. That is why it can attract the electrons towards itself more powerful, and that is why the covalent character will increase. Okay. Now, if the anion will be higher, if the anion will be, the size of the anion will be large, what will happen? For the large anion, that means the electrons are loosely bound. That means the electrons can easily distort towards the positive ion. That means the bonding character will be preferably for the covalent. Okay, so if the anion will be large, polarizability will be higher and the covalent character of the bond will be higher. This explains why for the common halides, iodides are the most covalent in nature. Okay, and large charge, if we have the charge on an ion increases, if the charges of the ions, positive or negative, increases, what will happen? If it is increases, that means the bonding character, the covalent character will also increases. The polarizability and polarizing power will also increases. So this is the Fajan's rule. Next, the large cations are to be found on the bottom left of the periodic table, and small anions of the top right. Already we know that if we go towards the down, then the size will increase, and if we go towards the right along the periods, the size will the size will decrease. Okay. The greater the positive charge, the smaller the cation become, and the ionic potential is a measure of the charge to radius ratio. Obviously, that is why the covalency increases in this order. You can see this picture. Look, sodium chloride, ionic character. Magnesium chloride, aluminum chloride. For aluminum chloride, the distortion is higher. That means for the aluminum chloride, the covalent character, bonding character will be higher. Here also for aluminum fluoride you can see, aluminum chloride you can see, and for aluminum bromide. For aluminum bromide, the covalent character is higher because of the size effect, because of the charge to radius ratio. Okay, so all this because of the charge to radius ratio is high. That is why covalent character will be higher. And lastly, according to the Fajan's rule, it stated that for cations with the same charge and size, if the electronic configuration will be n plus 1 dn ns0, which is found in transition elements, have greater covalent character than the cation with np2 ns2 np6 electronic configuration, which is commonly found in alkali or alkaline earth metal. Generally what will happen, also the covalent character also depend on the what is the electronic configuration of the cation. If the cation will have the inert gas configuration, that means the distortion will be very low. If the cation will have the pseudo fulfilled shell, so what will happen, the distortion will high, the covalent character will high. So that is why the distortion, the covalent character of the bond will also depend on the electronic configuration of the cation. So all these about the Fajan's rule. Fajan's rule, if we know well the Fajan's rule, then we can know actually the what should be the, for any bond, what should be the ionic character and what will be the covalent character. Okay, so this is for quick review. Just tell me, I have given one question. In between zinc chloride and magnesium chloride, which one is more covalent? Okay, now your time starts now. Yeah, your time is over. Now look at the question. Yeah, this is the answer. You are absolutely right. I think you know the answer. That is zinc chloride. What is the electronic configuration? 1:2, 2:2, 2p6, 3:2, 3p6, 3d10. And for chlorine, 1:2, 2:2, 2p6, 3:2, 3p6 is more covalent than the magnesium chloride. What is the electronic configuration for magnesium? 1:2, 2:2, 2p6, full-filled shell. Okay. Despite the zinc ion and magnesium plus 2 ion having the similar size and charges, almost magnesium and zinc have the similar size, but still the covalent character for the zinc chloride is higher than the magnesium chloride. Why? For the electronic configuration of the zinc. Okay, so zinc has this is the electronic configuration: 1:2, 2:2, 2p6, 3:2, 3p6, 3d10. And for magnesium, it's 1:2, 2:2, 2p6. That is full-filled shell. That is why for zinc chloride we are having the higher amount of covalent character for the bond that than the magnesium chloride. Okay, students. So this is all about the today's class. Today we have discussed about the Fajan's rule. So before knowing that, you should have the clear concept about the polarizing power and the polarizability. Okay, so after that, the Fajan's rule. If we know the what is the importance of Fajan's rule, if we know the Fajan's rule, we can tell that the what will be the percentage of ionic bond, what will be the percentage of valence bond, that we can tell by the Fajan's rule. Okay, so from this portion there are some of the questions I have given. From this portion, whatever questions you can have, like first question. Yeah, first question is, electron affinity of chlorine is greater than fluorine and fluorine is more electronegative than chlorine. Explain. Okay, electron affinity of chlorine is greater than the fluorine. But fluorine is more electronegative than the chlorine. Explain why. Now, before explaining this, first of all, you should know what is electronegativity and electron affinity. Electron affinity is just the reverse reverse process of the ionization energy. What like if in an outer orbital, if for an atom, if we add want to add one electron in the outer orbital of that atom, so minimum the energy release, the released amount of energy is called by the electron affinity. Okay, so electron affinity is defined as the energy released from an element in its gaseous state, stable gaseous state, for the addition of electron in an outer orbital. Okay, in the outer orbital. So this is called electron affinity. Now electronegativity. What is electronegativity? Electronegativity means the property to attract the bonded electron, generally the covalent bonded electron, towards itself, that is called by the electronegativity. Okay, so fluorine is more electronegative atom than the chlorine. This is clear because fluorine, the size of the fluorine is very small and the charge density is very high. So that is why the fluorine is more electronegative than the chlorine. But still the electron affinity of chlorine is greater than the fluorine. Okay, so what will happen, the tendency, the atom which will have the tendency to pull the electron towards itself, so for that atom the electron affinity should be low. Okay, electron affinity should be higher. But what will happen for the fluorine, this is the exceptional case. Why? Because of the charge to mass ratio. For the fluorine, the size is very small and charge density is very high. That is why if we want to add one extra electron in the outer orbital of the fluorine, is much more difficult than the chlorine atom. So this is the clue for this question. Ki the charge to mass ratio or the size of the fluorine is very small than the chlorine and the charge density is higher than the chlorine. Okay, so that is why though the fluorine is electronegative atom, electronegativity of fluorine is higher than the chlorine, but still the electron affinity is higher for the chlorine, not for the fluorine. Okay, now next question, write the factors that influence the polarizability. Okay, now what is polarizing power, what is polarizability? So already we know that polarizing power generally we are polarizing power generally is for the cation, and polarizability is for the anion. Okay. Now polarizing power, that means if one cation and anion will come to each other, what will happen? Anion means the on that element the electron density is very high, and cation means the electron deficient atom. Now while both will come to each other, what will happen? That that cation will have the tendency to attract the electron density whatever we have on the anion towards itself. So this power is called by the polarizing power, right? Okay. Now polarizability is the property of the anion. That means how the anion will be more how the electron or whatever electron density we have on the anion, how they distorted in presence of the cation. That is called by the polarizability. If higher polarizability, that means the electron density will distort, the distortion of the electron density or delocalization of the electron density towards the cation will be higher. Okay. So this is called the polarizability. Now what are the factors that influence the polarizability? If the anion will be very big, what will happen? If the anion will be very big, the size of the anion will be very big, what will happen? The electrons are loosely bound, so that electrons can very easily go towards the positive ion while they are facing the attraction force, right? So the distortion will be higher. The size factor, one of the factor influencing factor for the polarizability is the size. The higher the size, higher will be the polarizability. Okay. Next, what the higher if the charge of the anion will be higher, that means the electron density will be higher. We have very huge amount of electron density on the anion. What will happen? That time also the polarizability will be higher. So these are the some of the factors that is influencing the polarizability. Higher the polarizability, higher will be the covalent character of the bond, because the electron density will be distorted. Okay. So delocalized towards the delocalized towards the positive ion. So that means the what will happen? The covalent character of the bond will increase. Okay. So these are the some of the factors. Now how does the size of the atoms vary left to left, left to right in a period, and one descending the group in the periodic table? Okay, so this is very easy questions that we have already discussed, but still for your these type of questions are very common, so that's why I'm repeating again. That size, the trend of the size, mainly if we descending the group, if we go down the group, what will happen? The size will increase. Why? Because extra shells are added. While extra shells are added, that the nuclear power will be decreasing. That means the outermost orbital electrons are very loosely bound. That's why size will expand and the size will increase while we go down the group. Now, if we go along the period from left to right, what will happen? The extra electrons are added, as well as the extra nuclear charge is also added, also increases. So that is why what will happen? The nuclear charge, nuclear attraction force will increase to the outermost orbital electrons, and thus they will be bound to the nucleus more strongly. Okay, so that's why the size will contract, size contraction will take place, and thus the what will happen, thus the size will decreasing. So along the period from left to right, we have the size decrease in size, and from down the group we have the increase in size. Okay, now next question is the increasing order of reactivity among the group 1 elements is like this: lithium less than sodium, less than potassium, less than rubidium, less than cesium. Whereas for the group 17 element halogens, for the halogen elements, what will happen, the fluorine is greater than chlorine, greater than bromine, greater than iodine. Explain. Now what will reactivity, how reactivity depends on what factor reactivity depends. Reactivity depends on how easily one element will abstract the electron, or how easily they can release the electron. Okay, so if you can see the lithium, sodium, lithium is less than sodium, is less than potassium, the size is for you can see the size for the cesium atom is greater than the rubidium, than potassium, than sodium, than lithium. Okay, so what will happen, they can very easily release the outermost orbital electron. Okay, now for group 17 elements, they are electronegative atom, that means they are abstracting the electrons. So fluorine is higher electronegative than the chlorine, than bromine, than iodine. So that's why the reactivity order is like this. Okay, so reactivity means the electron transfer of the electron, or abstract of the electron. So the element which can easily remove the electron, or the element which can easily accept the electron, that is very reactive one. Okay, so this is the answer. Now what is the importance of Fajan's rule? You know, before Fajan's rule we have already discussed about the polarizing power and polarizability, right? Now what will happen, if the polarizing power is higher, that means the cation can distort the electron density on the anion in larger amount, and also polarizability is higher, that means the anion is the anion can easily distort its electron density towards the positive ion. So for that case, the covalent character of the bond will be higher. So if we know the Fajan's rule, we can know what will be the possibility for the ionic bond, what will be the possibility for the covalent bond. Okay, so this is the importance of Fajan's rule. So this is all about the today's class. Okay, so these are the general questions, these are the very common questions that you can have frequently in your exam. Okay, from this portion. So this is the recapitulation. Today we have discussed about the polarizability. Yes, polarizability we have discussed, the polarizing power we have discussed, and also at last we have discussed the Fajan's rule. Okay, yeah. Okay, so what now you have to do, first of all you have to follow the classes regularly and go through the study materials whatever given, and then you have to complete your assignment and submit it in the time. So thank you students, and see you in the next class.